The ultimate objective of modern machine learning is to create autonomous, generalist agents capable of navigating complex operating systems. We are building AI to use computers exactly like we do. In reinforcement learning, an agent learns to achieve a goal in an uncertain environment by maximizing its cumulative reward. While RL provides the mechanism for this improvement, the process requires a mathematically pristine reward signal to guide the agent's policy. Modern graphical user interfaces are inherently stochastic. Pop-ups suddenly appear, loading times randomly vary, and layouts shift unpredictably with every click. To complete a single task in this environment, an agent generates an incredibly dense trajectory. A typical session involves thousands of sequential microactions, rendered text changes, and shifting structural elements. The sheer volume of this continuous visual and structural data overwhelms traditional evaluation metrics. Simple rule-based scripts cannot track the massive number of moving parts. Without a flawless method to parse this chaotic trajectory into a reliable reward, the reinforcement learning optimization process mathematically collapses. The agent receives inaccurate feedback, and it learns nothing. The primary bottleneck to artificial general intelligence has shifted. Progress now depends on accurately scoring an agent's continuous, long-horizon behavior, rather than simply increasing its action capability. The industry standard feeds the entire action sequence into a single large language model, acting as a monolithic judge to output a pass or fail score. But long-horizon tasks easily saturate the model's context window, resulting in heavy reasoning degradation. A single hallucinated frame or a missed contextual clue buried in that long sequence can cause the single judge to flip its verdict entirely, generating a false success. A noisy reward function actively degrades the agent. It teaches the model to optimize for these hallucinated successes rather than actual task completion. Researchers Lee and colleagues have engineered OS-Themis, a framework that abandons the single-judge monolith entirely. OS-Themis is a multi-agent critic system designed to systematically dismantle agent trajectories and rigorously audit the underlying evidence before making a decision. OS-Themis addresses the scalability crisis by shifting reward generation from a monolithic, subjective guess to a decentralized, mathematically verifiable audit. The complete OS-Themis architecture operates as a strict three-stage pipeline: decompose, extract, and audit. The first functional step is trajectory decomposition. Instead of looking at a continuous run of actions, the framework actively slices the trajectory into isolated logical steps. Each sliced block is defined not as an arbitrary span of time, but as a discrete, verifiable milestone. This discrete slicing is computationally superior because it instantly localizes the evaluation scope. The system isolates exactly what needs to be verified, dropping the excess context. Trajectory decomposition reduces a mathematically intractable long-horizon problem into a series of strictly bound, solvable equations. With the problem separated into discrete steps, the system must extract the objective ground truth. The evidence extractor node executes a singular function, mechanically pulling observable data directly from the environment, including screen coordinates, interface text, and the document object model. This removes subjective guesswork, relying purely on the raw structural state of the user interface. A strict operational rule is enforced here. A milestone cannot be considered achieved without the specific, verifiable proof of the interface state. This process immediately halts the dangerous hallucination loop. The critic cannot invent a success if the exact text or coordinate data does not physically exist in the isolated packet. By tying rewards strictly to this isolated, observable data, OS-Themis anchors the agent's progress in absolute, verifiable reality. The final failsafe in the OS-Themis architecture is the review mechanism. Raw extracted evidence isn't enough on its own. It must be rigorously audited against the agent's original intended action. The evidence packets are sent flowing through a series of strict logic gates where they are compared directly against a verified static rubric. This strict auditing eliminates false positives by enforcing a rigid evidence chain before any numerical reward is issued. This multi-agent approach scales seamlessly. The cognitive auditing logic is completely decoupled from the massive raw data extraction process. This three-step pipeline, decompose, extract, audit, creates a deterministic, high-fidelity reward signal that reinforcement learning algorithms can trust. Moving from a theoretical architecture to real-world application requires rigorous empirical proof. Establishing this architecture required a new evaluation standard, leading the authors to introduce OmniGUIRewardBench, or OGRBench. OGRBench is a holistic, cross-platform benchmark specifically engineered to rigorously test graphical user interface outcome rewards across diverse models. This radar chart plots model performance on the benchmark. All evaluated foundational models achieved their absolute highest performance when placed inside the OS-Themis framework. This results show OS-Themis is strictly model agnostic. It improves outcomes regardless of the specific language model you utilize. The framework effectively raises the reasoning floor of any underlying model by structuring its cognitive process into a verifiable sequence. OGRBench objectively verifies OS-Themis as the leading framework for reward generation across all major operating system environments. The final, most critical test is applying the OS-Themis framework to live dynamic agent training in the AndroidWorld environment. The first practical application is injecting OS-Themis's high-fidelity rewards directly into an online reinforcement learning loop. This dual-axis bar chart tracks the resulting agent performance. Utilizing OS-Themis in online reinforcement learning yields a 10.3% improvement in agent capabilities. The second application utilizes the framework for trajectory validation and filtering within a self-training loop, producing a 6.9% gain. This strict filtering protects the agent during self-training, preventing it from ingesting flawed data and learning from its own hallucinated successes. These metrics prove that more rigorous evaluation directly and measurably accelerates true policy convergence in autonomous agents. Scalable agent evolution can no longer rely on the intuition of massive, single models attempting to evaluate chaotic, continuous data. Future breakthroughs in generalist GUI agents depend on this transition to verifiable evidence auditing, as established by the OS-Themis framework.